Okay, good morning, everybody. Welcome to, this is week 13. So we have 3 weeks officially left of school. Give me one sec. Give me one sec.
3 weeks left.
Yeah, there's only 3 weeks left, including this one. So week 13, week 14, week 15. I think a little bit of week 16. So look, 3.5 weeks, I think, total. So it's gonna go by pretty quickly. So yeah, I'm kind of glad. I want the semesters end as quickly as possible so I can move on. So
I had a question in regards to just general academic, Dr. Kim. So
yeah.
did every student professor lose a week because of the bye week from the pandemic that we had?
Yeah.
Okay, so we didn't extend at all. We just lost.
No, we basically, I mean, in my case, I basically condensed or removed certain items to accommodate those that one lost week, basically. I don't know what other people did, but yeah, we didn't gain that week back. So everything else is as planned before.
Okay.
So yeah. I don't know what other people did. I basically moved certain things around and I removed certain parts because we lost 3 lectures basically. So yeah. Okay. Any other questions before we begin? Nope. So today is the review, exam review. So exam 2 is going to happen on Wednesday. It'll be, so all of you guys should have gotten an email from me. My apologies. Blackboard tends to change the formatting on those emails for some reason. It was like the alignment on the bullet points were somehow really off. So, or they were skipping lines for some reason. I'll try to send it through Gmail next time, but that's extra work for me. So try out that test exam on Blackboard. If your test fails on Wednesday and you haven't really tried this out, even though I've given you all of the instructions and set up a test for you, a trial, that's on you. So you need to try that out ASAP. If you run into an issue, you need to find out what that issue is right now, okay? Because that's the whole point of setting up those trials. All right. So if you try to email me on the day of and say, oh, nothing's working, and it turns out you never even tried it, that's on you. Okay. So you need to make sure you test these things out on your own. Okay.
Dr. Kim?
Yeah.
Is it just like we go in there and make sure everything's working, or we have to actually solve something or whatever?
There's 2 questions on the trial. So the first thing I'm really checking is, can you follow the instructions and go through respond this, right?
Gotcha.
Yeah, a lot of people are going straight through Blackboard. It will block you. It'll automatically generate a password. Yeah, I don't know what that password is either. So it's doing that, so it blocks you from gaining it, accessing it through Chrome or other web browser. So you have to do it through the Response web browser. So there's really the first check. Second check is, does all of the equipment work fine, right? So, because you're gonna have to do those pre-test trials. There's 2 questions on there. They're just nonsense questions, like how many days in a leap year, right? I mean, just put in an answer. I'm not checking for right or wrong. I'm just making sure because once it shows up that you answered it, then I know you went through the trial successfully. Right?
Gotcha.
So so try doing it. It shouldn't take you too long. I just want you to get used to it, and I have a confirmation that it works on your end.
Understood. Thank you.
Yeah. Okay. Any other questions? Logistics? Nope. So I'm gonna head over to the. I'm gonna use my tablet here. So I'm gonna go here, and I will now share with you. Let me share this guy right here first. All right. So some of the basic stuff is the same as the first exam. I kind of laid out what the main topics were over the last 5 weeks or so. Exponential distribution and Poisson, basically, and CTMC, right? They're all linked together anyways. So all of those topics are our main topics. You're allowed to use a calculator. You should have, I would say, at least 3 or 4 pieces of paper in front of you, blank sheets. And when you do your pre-test, make sure you lay those out so I can clearly see those are just empty pieces of paper. 1 page of notes, front and back. And I did send out the instructions. You can print that out and have that on the side as well. Instructions on the respond this part. That was attached to the email. And remember, all of these instructions are also on our shared document on Google Docs. that's been up since we made this transition. So there's in multiple places. So if you're still not clear, just email me so I can clarify something for you. You can have those things on your desk, and you should basically just imagine you're in an exam room, but you just happen to be all by yourself, right? So once you get on Respondent, it is a lockdown browser. You can't really use anything else. Make sure you only have one laptop or one screen on your desk. Okay, so in my exam, honestly, I don't even know if anything else really helps. It's just gonna be distracting for you. So one laptop, just have your webcam on, have your audio on, take your exam, and just treat it like any other exam you would have done in class. Okay. Obviously, no communication, right? No smartphone, no extra tablets, extra laptops anywhere. Book, lecture notes, none of that. Just your page of notes, empty sheets of paper where you can write out your answers or work out the problems. After the exam, you should scan all the pages that you use in the exam, and then submit that. There's a separate link on Blackboard. And now this is on Blackboard, not on Respondus. The separate link on Blackboard, just like you would do turn in homework. You're turning your exam work using that link. This is the only way for me to give you partial credit, right? You should input your answers on Respondus. Okay, you put your answers in there, and hopefully you get it right. Then I don't even have to look at your work very carefully. But if you get it wrong, I want to give you partial credit, right? So then I need to go back and look at the work you did. So make sure you number your questions so that I can follow along. If you just put stuff all over the place and I can't follow, I can't give you any extra points. So just treat it like a real exam. Just number them 1, 2, 1A, 1B, etc. Right? Just go in that order, or whichever. The ordering doesn't matter. Make sure it's clearly labeled, and make sure you submit that as a support document to the answers you provide on Respondus. Okay. Hopefully that's clear. Okay, and that's really just so that I can give you as much partial credit as possible. Okay. Any questions for me on the logistics? Again, I strongly encourage you to try out that trial on Blackboard. That's the only way we both know, you and I both know, especially you yourself, that you know exactly what to expect on Wednesday. Okay. If nothing else, then I will get started. Oh, by the way, there's also a additional formula sheet that's going to be on the exam. Like when you scroll down on the exam on the last problem, it's not really a problem. It's 0 points. You'll see a couple equations there. That's just there for you to use. Okay, so I can't really attach a equation sheet, but that's one way for me to give you some equations that you may need without doing something extra. Okay, so the last problem on the exam, you don't have to answer anything. It's just a reference for you. Okay. All right, let's get started with the first review. Are there any specific review problems that you might go over, or should I just go in order that it's given? No? Okay. So now I'm going to continue. I'm going to keep going. If there's no other questions. Let's see. Okay. So number 1, A, x1, x2, and x3 are exponential random variables. All IID, that means identically independent, identically distributed. So basically, they're all exponential random variables, but they have different lambdas. Okay. A, I want the probability that x1 is less than x2, less than x3. Part B, let's just start with A. Okay. Let me change the color here. All right, okay, let's see. Part A, oops. Okay, I want the probability x1 is less than x2, is less than x3. Okay. Multiple ways to do this. The first way, I think, an easier way to look at this is like saying probability that x2 is less than x3, given that the minimum of x1, x2, x3 equals to x1 times the probability that the minimum x1, x2, x3 equals to x1. Okay, so if you look at these two expressions, they match this in a sense, right? This is saying x1 is smaller than all three, which is given by this part over here. Okay, the probability of that happening. Given that that's true, then x2 then has to be less than x3. Okay, so the expression on the left of the equal sign and the right of the equal sign are basically equivalent, okay? But this is easier now for us to solve. Okay, let's start with this part over here. Okay, what's the probability that x1 is a minimum of all three? How do I get the minimum of all three exponential variables? Any ideas? So if it's just two variable, let's say it was a minimum of x1 and x2, and let's say that was x1, or let's say x2, what is that equal to? If we're just looking at two variables, I want a probability. This is like saying same thing as probably that x2 is less than, x2 is less than x1. Okay, let's ignore the three variable case first. Let's look at just two variables, x1 and x2. What's the probability that x2 is, go ahead.
Is it just x2 over x1 plus x2?
You mean lambda, right? Lambda 2.
Sorry, yeah.
Yeah, lambda 2 over lambda 1 plus lambda 2, right? Yeah, exactly. Now, if you have three variables, what would this look like?
Lambda 1 over lambda 1 plus lambda 2.
More confidently, folks. Yeah, it's lambda 1 over all the other lambdas, okay?
Yeah.
All right, so it's the same concept applies whether you have two variables or three variables, four variables, the same concept. Okay, so that part is at lambda 1 over lambda 1 plus lambda 2 plus lambda 3. All right, so how about this part then? What's the probability that x2 is less than x3 given that the first part already happened?
Lambda 2 over lambda 2 plus lambda 3 times what you just wrote down, lambda 1 over lambda 1 plus lambda 2 plus lambda 2.
Yeah. So you're right. So that's what you just said is actually the final answer, right? This given part is you don't really have to, you do account for already when you write down lambda 2 over lambda plus lambda 3, right? So this whole thing ends up becoming lambda 2 over lambda 2 plus lambda 3 times lambda 1 over lambda 1 plus lambda 2 plus lambda 3. That's my final answer. Okay. All right, that's my answer. Okay, any questions on this result? Nope, okay, part B. All right, I wanna know the probability x1 is less than x2 given max of x1, x2, x3 equals x3. Okay, so this again, I think this is a problem where if you don't know how to kind of, well, you can confuse yourself a lot in this problem, I think, even though it's a pretty simple problem. I'm gonna rewrite this. Don't forget what you already learned, right? Conditional probability, right? This is just A, that's B, right? So at the numerator, it's gonna be probably A and B. So if I write A and B, if x1 is less than x2 and the maximum of all three is x3, then the end statement is basically probability of x1 is less than x2, less than x3, right? If this is the same as A and B, right? Okay, the same thing as saying A and B, right? Okay. Right, same thing, right? And then in the denominator, you have the probability of the max of x1, x2, x3 being equal to x3. Okay.
Dr. Kim, I'm sorry, so you're dividing it by that?
Yeah. Remember, when you have, I'll write it down here. When you have probability of A given B, this is just conditional probability statement, right? The probability of A and B over probability of B, right? I'm just using that conditional statement, right? A and B on top. If I rewrite A and B, x1 has to be less than x2 and x3 has to be bigger than all three of them. Then it's like saying probability of x1 is less than x2, less than x3. Divided by my B part, which is the probability that the maximum of all three is x3. Okay, I'm just using the definition of conditional probability. Okay. Any questions? Any other clarifications you guys need? Okay, so right away, you look at the numerator. What does that remind you of?
The first part.
Yeah, this
Yeah,
is
of the last problem. It's the solution to the last problem.
yeah, this is part A, right? Okay, we already got this from part A, right? So we just have to then deal with the denominator, right? Okay, so if I just look at the denominator, probability of max x1, x2, x3 has to equal x3. So this is a probability where x3 is always the biggest number, right, out of those three. Okay, so if that's the case, can't I just rewrite this as the probability of x1 less than x2 plus x3 plus the probability of x2 less than x1 less than x3? Are these equivalent statements? I want to know the probability that x3 is the maximum of all three. The only
Yeah.
two, yeah, right? Yeah,
That makes sense. Yeah.
yeah. Then if you now take a quick closer look again, the first part, this first part, we already have, right? That's also from part A, right? That's also from part A, right? So we're just left with this part that we have to deal with, right? Probability that x2 is less than x1, less than x3. Okay, I'll write over here. And you can kind of tell how you would then solve this, right? We're going to use the same logic as we did in part A. Okay, so then this is going to end up being, let's see, lambda 2. Let's see, I'm going to do lambda 1 over lambda 1 plus lambda 3. Okay, and I'll kind of highlight this after I write it all out. Okay, and then lambda 2 over lambda 1 plus lambda 2 plus lambda 3. Okay, so let me highlight this part here. Okay, this first portion is like this first portion, right? Given that the minimum author is x2, what's the probability that instead of x2 less than x3, it's going to be x1 less than, oops. What did I do there? X1 is less than x2. I mean, x2 is less than x1, right? So, I'm sorry, x1 is less than x3. That's going to be this portion right there. X1 is less than x3. This portion is x2 is less than all of them, right? Okay, so then if we put everything together, it's just algebra at this point. Then the whole thing ends up being, it's kind of get kind of messy. I try to write it all in. It's going to be lambda 2 over lambda 2 plus lambda 3. That's the numerator. Lambda 1 over lambda 1 plus lambda 2 plus lambda 3 divided by the same expression, lambda 2 over lambda 2 plus lambda 3, lambda 1 over lambda 1 plus lambda 2 plus lambda 3 plus lambda 1 over lambda 1 plus lambda 3 times lambda 2 over lambda 1 plus lambda 2 plus lambda 3. Okay. If you leave it like this, it's fine. This is simplified enough for me. That's the answer for part B. Okay. Any questions?
Can you second to just like gather all of that, you know? Just
Did the last part? I'm sorry. Your question was?
Oh, I'm just asking if you give us time before you move on to the next part.
Oh yeah, sure. This is gonna be posted too, so Yeah, but yeah, I'll leave it there. I think Mohammed or Fawaz or both of you guys had a comment.
Yeah, Dr. Kim, how are we
Yeah.
supposed to write this expression during the exam, like into responders? Like, how are we supposed to type this in, or I don't know.
I mean, I could make you guys do that and make your life miserable, or just give you multiple choice answers, I guess. If it's something this kind, more than likely, what I'll do is I'll give you the actual values, like numbers. Then you can plug in the numbers and get an answer, right? And you'll just type in that answer.
So, like, the majority of the exam is going to be numerical values.
Yeah. So I'll give you what lambda 1 is, lambda 2 is, lambda 3 is, and then you just plug those values in, and then you write that answer in. There may be multiple choice. I don't know. I haven't converted the test into responders yet. But yeah, maybe I should. Yeah, it's gonna be a painful thing for you to put in all of this symbols. So yeah, yeah, but it'll be. I mean, I'll try to make it easier. So I think the easiest is I'll just give you the values.
Okay.
Does that answer your question, Mohammed?
Yeah.
Okay. Any other questions, comments?
Yeah, Professor, I have a question on the set of problems on the review, just a general one.
Mm-hmm.
So I have, for the first problem, I look at the solution, but I don't know why we didn't use the property when it's the birth and death property, which is 1 over lambda thing.
I mean, I guess you could have. I don't remember the problem exactly, but let me okay. Let me get through this
Okay.
these problems, and then I'll answer that question. I
Okay.
gotta look at the problem, but so let me give you a general comment though. A lot of these questions, there's multiple ways to solve it. So you might be
Okay.
right.
Okay.
Yeah, you might be right. I just may have taken one way to do it, but there's multiple ways usually.
Okay. Okay.
Okay. All right. Part C. Okay. Part C is asking for the expected max. So it's looking at the expected value now, not the probability, but the expected value, maximum xi, given that x1 is less than x2 is less than x3. Okay, so if you look at this, which one's going to be the biggest? Which one's going to be the maximum out of x1, x2, and x3? Which one is the biggest?
X3.
X3, it's given, right? Okay, so again, the way you think about this is a timeline. Okay, the first event, this is x1, right? That's the time it takes for the first one to occur. Okay, x2 is going to be from 0 to all the way out here. That's x2, and then from 0 to the last one, this is x3, right? So this is like saying the expected value of x1 plus the expected value, and then you can kind of think of, like, let's say there's 3 servers. So there's this is person 1, person 2, person 3. The first one, expected value of x1, is just the minimum of all 3, right? So this is 1 over lambda 1 plus lambda 2 plus lambda 3. The second one is really the minimum between x2 and x3, okay? Because first person leaves, right? First person has left, right? They're finished, right? You only have x2 and x3 left, okay? So it's given that x2 finishes before x3, so the time it takes for x2 to finish, the additional time, right when the first person leaves, okay, it's like going from 0 again, right? So the expected time, this stretch, I'll call this S, okay? I'll call it S2. This is like the expected value, S2. What would that be? How long does it take for that second person to leave, right after the first person leaves? How much time does it take for that second person to leave?
Is it 1 over lambda 2 plus lambda 3?
Yeah, exactly, right? 1 over lambda 2 plus lambda 3. If this person leaves, okay. Then how long does it take for that third person to leave? I'll call it S3. How long does that does it take for the third person to leave? just kind of look at the picture. How long does it take right after the second person leaves? What's the additional time for that third person to leave?
1 over lambda 3.
1 over lambda 3. This is your answer. Okay. So that's the
Dr.
answer.
Kim,
Yeah.
I know this is like, it's simple. I just have a question. So like for x2 or for x2 value that we looked up on the line graph or whatever you want to call it, line chart.
Yeah.
Okay. We said that the answer is 1 over lambda 2 plus lambda 3, but we established initially that lambda 3 was the largest value. So we don't assume that the second event happens first, or what?
We do. The second event happens. You mean the? Okay, let me rephrase this way. X1 is the first person. X2 is the second person. And X3 is the third person, right?
Yeah.
The second person leaves before the third person.
Correct.
Yeah, and that's what the diagram also shows, right? X2 happens earlier before X3.
Oh.
Yeah.
I guess I'm just thinking like if it's the memoryless prop. Yeah, I guess it makes sense. I guess I'm just like confusing it. I'm adding more stuff to it.
So Io, there's really one critical conceptual thing that many students I bet are still kind of struggling with, and they often don't remember or they don't fully grasp. Is if I say the expected value of x2, the second person, that's just 1 over lambda 2, right?
Yes. Yeah.
If it's the expected value of x2, given that x2 is less than x1 though, this is 1 over lambda 1 plus lambda 2. If the expected value of x2, given the minimum of all three, is let's say x2.
1 over all the lambdas.
1 over all the lambdas, exactly, right.
Gotcha.
Now let me do another one. What if this was x1? If I change it to x1, what happens?
If you change the
this part, I just changed it to x1.
Given that x2 is less than
x1. I'm sorry. Let me change that too. I gotta change these two as well. Okay. If x1 is less than, what's the expected value of x1 given that x1 is less than x2?
Would it be just 1 over lambda 1?
No, it's 1 over lambda 1 plus lambda 2 again, right?
Okay.
If this is lambda 1 right here, this would be lambda 1, right? But again, based on the condition, everything changes.
Okay.
Right, but the fact that we know it's a minimum, that result is also an exponential function with just the lambdas combined.
Okay, so as long as you're saying that if you implicate something else, has to show up in the denominator, basically.
If the condition is that something's the minimum
of two or multiple.
Of 2 or more, of 2 or more exponential functions, then the expected time for that minimum event to happen is just 1 over all the lambdas combined.
Gotcha.
Yeah. Okay, so this is, I think the key difference, again, is expected value of x1 is not the same as the expected value of x1, given that x1 is less than x2. Okay, that's I think it's crucial that you understand that, right? Because you might say, because you might say that, okay, if we know the person in server 1 finished first, isn't it always 1 over lambda 1 because they're already there, right? It's not. If you're given that, if you're given that they finished earlier than somebody else, right away that time changes because it's an exponential function. That's really the beauty of the exponential function. Is it's embedded in that whole statement. It's the whole memoryless property. It's got a bunch of properties embedded in there, and that's often what allows us to solve problems a lot easier.
Definitely.
Okay.
Well, thank you for letting me know that now. Thanks for clarifying.
I think some other students who are listening right now are, hopefully that helps them too, because this I think is.
Thank you.
Yeah, that's always a struggle for a lot of people because it seems completely illogical, right?
But I was looking at the line graph, and I'm like, if we know x2 happened first, then why do we care about the cumulative time of x2 and x3? I guess it's what's at the minimum.
Yeah. And when you actually look at a real case problem, when you collect data and you do this kind of analysis, if you model it this way, it turns out exactly like this again. So yeah, it's like magic. That's what I always say. It's just like magic. It happens and it works really well. Okay.
It works like that in the test too.
Oh yeah, we have to know how to do it. Yeah, exactly. Any other questions, comments? Nope. Okay. We're going to move on to the second problem then. Green men arrive at the launching pad according to a pulsar process rate mu equals to 2. And red men arrive according to pulsar process rate lambda equals 3. The spaceship leaves when there are 3 men of either color at the pad. What is the expected time required to fill the spaceship? All right, so this again, I think hopefully this is not that overwhelming for you because this is again, I think my first advice for a lot of you is when you read stuff like this, don't panic, number one, okay? There's nothing here that I'm gonna ask that's unreachable, right? I'm not gonna ask anything that's unreasonable, right? So it's gotta be something that is relevant to what we already did, right? Something that's not a complete stretch, right? I don't have a bag of tricks that I'm gonna pull out, right? It's just gonna be same stuff we already learned, right? So I have this, let's say this is my space pad, and you have a rocket that's about to leave. Green men arrive at a rate lambda equals to 2. Red men arrive at a rate of 3, whatever that time unit might be, okay? I wanna know expected time to require the spaceship. There's a space for 3 people, right? So you're really asking the expected time until the third person arrives. Okay, everyone agree? You're just waiting for the third person to arrive? You start from nobody, and then yeah.
Dr. Kim, I think your units are wrong. Mu equals 2, and it's for the green guys.
Oh yeah, I'm sorry. Yeah. So I have this switched, right?
Yeah.
So this is okay. Red man is me. Oh, okay.
Yeah,
okay.
yeah.
I see. Okay. Why red man? Green is 2, so mu equals to 2, and then
Yeah, mu
lambda
equals 2.
equals 3. Okay. All right. Then we're waiting for the third person to arrive. Okay. So how would you formulate this problem? Initially, time 0, nobody's there, right? Okay. First person arrives. Okay. How long does it take for this first person to arrive?
The minimum of their 2 times. So 1 over lambda 1 and mu 1, or
1 over
lambda and mu.
lambda plus mu. Yeah, that's it.
Yeah.
So this is 1 over lambda plus mu, right? Okay. So right after the first person arrives, the second person will arrive, right? How long does this time take? How long does it take from the first arrival to the next arrival? How long does it take?
1 over lambda plus mu.
Yeah, it's again the expected value of the minimum between G and R again, right? Okay, and then let's say the third person arrives. I'll draw it this way, but it doesn't really affect our result. I'll call it X3. How long does it take from the second arrival to the third arrival? How long does that take?
It would just be the lambda then, right? Or it would be x3, but
What? Well, X3, I'm just putting X3 as the time between the second arrival to the third arrival, right? So how long does it take for the third arrival to happen?
It should be the same, right?
It's the same again, yeah. It's always
Yeah.
the minimum. Because green men and red men, they're all both arriving, right? So then it's always the minimum between those two, so that the expected time is 1 over lambda plus mu. So the answer is 3 over lambda plus mu. So let me ask you another continuation of this conceptual question. I just had a green man arrive. A green man has just arrived. How long does it take for the next green man to arrive?
Lambda 1 or lambda, was it green? Yeah, green. Lambda over lambda plus mu.
No, what? Oh, that's the probability. You just told me the probability that the red men arrive. How long does it take?
Oh, you're right.
How long does it take for the next green man to arrive? I just had somebody arrive. Yeah, anybody.
Is it the still minimum between the two?
No, it's not the minimum anymore.
Is it 1 over lambda?
1 over mu, right?
No.
Oh,
If it's
mu, sorry.
Yeah, green is mu. So If it's red, it's 1 over lambda. If it's green, it's 1 over mu, right? If I were to tell you then, right now, somebody just arrived, right? What's the expected time for the next green man to arrive, given that the next arrival is a green man? What's that expression? What's that equal to? Let me write it this way. Expected time of next green. What's that again? What's the expected time to the next green person? 1 over mu, right? What is expected next green, given that the next arrival is green? So green arrives before the next red. What is that equal to?
1 over lambda plus mu.
Yeah, 1 over lambda plus mu. Yeah. So the same idea, right? If you just look at G, green, it's 1 over mu, but given that green is the next event, it's the minimum between green and red, now it's lambda plus 1 over lambda plus mu. Let me rewrite that, it's messy. Yeah, same idea as the last problem, right? If it's a minimum, it changes, right? If you have a minimum condition, it changes. Okay. Okay, part B. What's the probability that the crew are all green? Okay, so you have 3 arrivals happening, right? 0, 1, 2, 3, right? Okay, what's the probability that the next person arriving is green?
Mu over mu plus lambda.
Mu over mu plus lambda, exactly, right? Okay, right? Right after that happens, what's the probability that the next arrival is also green?
It's also going to be mu over mu plus lambda.
Yeah, right?
Dude,
So yeah, so if you want probability, all 3 are green, then what does it end up being? It's just mu over mu plus lambda, third power, right? 3 in a row, right? Okay.
Cool.
What if the probability? What if the question asks, what's the probability that probability that all crew are red?
It's lambda over mu plus lambda.
Exactly, right. Okay. Yeah, it would just be lambda because the next arrival is a red versus a green one, right? Okay, so mu over, so this will be 3 over 5 to the third power. I'm sorry, not 3, 2. Right, the mu is 2. Okay.
Professor?
Yeah.
So what if the question was, what's the expected time to fill the spaceship with all green men?
It'll
Is
still
it
be
just 1 over mu, 1 over mu, 1 over mu?
no, no. It'll still be the same answer as
The
part
same
A.
answer.
As
Okay.
part A, right?
Okay.
Because now, if you say it's only green men arriving, what you're saying is correct, right? But it's both green and red, right?
Yeah, okay.
Yeah. So the expected time was the same answer as A. Really, part B, it doesn't matter what combination of red and green. The expected time of the third person to arrive is going to be 3 over lambda plus mu, regardless of what combination it is.
Okay.
Okay, because it's the next event is either green or red. I mean, it's always going to be the minimum time. Okay. All right. Any other questions on this one? Let me go to the third problem. Small barber shop operated by a single barber has room for at most 2 customers. Potential customers arrive at a post-on rate of 3 per hour, and successive service times are independent exponent intervals with mean 1 over 4 hour. This problem is probably the longest one on the set. I can already tell. Okay, what's the average number of customers in the shop? Okay, so what's my lambda rate here? You have a barber shop, right? You have people arriving, and they get service and they leave. What's the rate of arrival here?
3.
It's not 3. 3 is the service rate, right? Oh, no, it is 3. I'm
1
sorry.
over 20 minutes. Oh,
Yeah, it is. It is. You're right. I'm sorry. It's 3 per hour or 20 minutes. Not 20 minutes. The expected time of service is 20 minutes. So that means 3 per hour. What's the service rate? I'm sorry. I meant to say service rate.
oh, 15 minutes.
15 minutes, right? But remember, we need it as a rate, right?
Yeah, so 1 over 15, or was it
1 over 15 per minute, right? But you want it in hours because, so lambda here is 3 per hour, right? you have to make sure lambda and mu are in the same unit. So mu here is going to be 1/4 of an hour is 15 minutes. It's 1/15 per minute, right? And then I'm going to convert this to hour then. This will be 4 per hour, right? Lambda is 3, mu is 4 per hour then. Okay. If I draw the rate diagram, 0, the states represent the number of people in the barbershop. You have this, lambda 0, lambda 1, mu 1, mu 2, right? In this case though, lambda 0, lambda 1, they're all both equal to the same lambda. Mu 1, mu 2 is just mu equals to 4, okay? All right, so then I'm gonna just set up the equations here. Radian equals, if I wanna find out part A, really the whole problem, I have to figure out what P0, P1, and P2 are. So then we're gonna look at state 0, radian mu 1, P1 has to equal mu 0, lambda 0, P0. If I look at state 1, it's going to be lambda 0, P0 plus mu 2, P2 has to equal mu 1 plus lambda 1 times P1. And then state 2, lambda 1, P1 has to equal mu 2, P2. And then the final equation, P0 plus P1 plus P2 has to equal 1. All right. Any questions on how I set this up? So I'm going to solve for P0, right? If I want to do any of this, I got to get P0 first, right? Usually that's not always, but usually that's the required step, okay? Because otherwise it's going to be a lot more difficult to solve. So I'm going to solve this. So I'm going to use this finite equation. I can turn P1 into lambda 0 over mu 1 P0. Okay. I now need an expression for P2. P2 I can get over here. It's going to be P2 equals to lambda 1 over mu 1 P1, which I can then plug it in and say lambda 1 over mu 2 times lambda 0 mu 1 P0, right? Since all the lambdas and mu's are the same, then this whole thing is just going to be lambda over mu squared, and this is just lambda over mu P0. So I'm going to plug it into this final equation here. P0 plus lambda over mu P0 plus lambda over mu squared P0 equals to 1. I'm going to solve for P0. So P0, sorry, 1 plus lambda over mu plus lambda over mu squared equals to 1. I'll put it over here. P0 then is going to be 1 plus lambda over mu plus lambda over mu whole thing squared inverted. So then P0 is 1 plus 3/4 plus 3/4 whole thing squared inverted. So then if you plug all of this in, you should get P0 37 divided by 16 inverted. So then it's going to be 16 over 37. So that's P0. That gives me P0. Okay. What am I solving for when I get for part A? What is the average number of customers in the shop? What am I actually solving for? I want the expected number of people in my barbershop, right? What does P0 tell me?
Amount of time that it's empty.
Okay. What does P1 tell me?
Amount of time that I'm servicing one person.
And then P2?
When I'm servicing one person and one person's waiting inside.
Okay. Then if I want the average number of customers in the shop, what do I do with those P0, P1, and P2?
You just 1 minus whatever values you need. So 1 minus P1 tells, or P0 tells you that your shop is empty. 1 minus P1 tells you that there's one person in the chair. 1 minus P2 means that there's someone in the chair and in the shop.
So I think you're overcomplicating it, right? So
Oh,
if you
I
have,
could be.
yeah. So if you have P0, P1, and P2, that those tell you probabilities, right? Okay.
Yeah.
Then we just have to take the expected value. Then that'll tell us the average number of customers in the shop, right? So let me see if I can put it this way. Okay. So part A is I'm looking for the average number of customers in the shop. So average number in shop. Okay. That's like saying, and then reasonably this is not true. It's like saying if you're at P0, you have nobody in the shop, right? So it's 0 times. If you're at P1, you have 1 person in the shop, right? If you're at P2, you have 2 people in the shop, right? Wouldn't that tell me the average number of people in the shop then? That expression, 0 times P0 plus 1 times P1 plus 2 times P2, right? Because if you're at P1, you have 1 person in the shop. Okay, if you're at P2, you have 2 people in the shop, right? So then if you average this, it's like taking the expected value, right? Remember the expected value of random variable x, the summation of xj, probability of xj, right? Same idea here, right? Okay, so then we know what P0 is, we just solved for it. It's going to be 16 over 37. P1, we know it was just lambda over mu, P0. So it's 3/4 over 16 over 37. And then P2, I think it was lambda over mu squared P0. So it's 3/4 squared P0. Okay, so I'm going to put in my P0 there, 16 over 37. So if I solve this all out, 0 times 0 is going to go away, so I'm going to just leave it. P1 is going to be 3/4, 16 over 37 plus 2 times 3/4 square times 16 over 37. You plug all of that in, you're going to get 30 over 37. Okay, so this is the expected number of people you find in the shop. Okay. Part B. Any questions? Okay, part B, it's asking for what is the proportion of potential customers that enter the shop. Okay, so when does so it says that there's room for at most 2 customers. So I should have clarified this. If a customer arrives and they find like there's more than it's already full, they won't come in. Okay, so at which state do you at which states do you expect people to actually enter the system?
0 and 1.
State 1
And 0.
and 0, right? Exactly. State 0 and state 1, right? So you can say the proportion of customers entering, it's like saying 1 minus P2 or P0 plus P1. They're going to be the same, right? Okay. Because P0 plus P1 plus P2 equals to 1, you really just need P0 plus P1, right? So then this becomes 16 over 37 plus P1 3/4 over 16 over 37. The whole thing becomes 28 over 37. Okay, that's the answer. Okay. Part C, if the barber could work twice as fast, how much more business would he do? Okay, so what changes in this problem?
Mu.
Mu, right? Mu is now 8, right? 8 per hour now. Okay. So I would just have to, I'm not going to do it here. You just resolve, right? You go back and you solve for P0, P1, and P2. It turns out P0 is going to be 64 over 97. And then P0 plus P1 then becomes 88 over 97. Okay, so initially you had lambda times 28 over 37 people arriving. So this is going to be per hour rate, right? So this is customer per hour. The new rate is going to be lambda times 88 over 97 customer per hour. Okay, so you just subtract these two, right? So you do lambda times 88 over 97 minus 28 over 37. It's going to be roughly 0.45 customers per hour. Okay, so if you assume the barber works, let's say 10 hours a day, he's going to be serving about 4 more customers per day. Okay, if he works 10 hours and he does that, let's say 10 days in a row, that's 45 more customers he'll serve. Okay. All right, we have 4 minutes. So any questions so far? We don't have time to do everything, so let's kind of, which one do you want me to do? Number 4 or number 5? Number 4 is super easy, so let's just do number 5. Or I'm sorry, did someone have a suggestion or?
We do 5.
5? Okay, let's do 5. In a certain system, a customer must first be served by server 1 and then by server 2. The service times of server I are exponential rate mu I. On arrival, finding server 1 busy waits in line for that server. Upon completion of service at server 1, a customer either enters service with server 2 if that server is free, or else remains in with server 1, blocking any other customer from entering service until server 2 is free. Customers depart the system after being served by server 2. Suppose when you arrive, there's one customer in the system and that customer is being served by server 1. What is the total expected time you spend in the system? So in rough diagram, server 1, server 2. Okay, so you arrive. Right when you arrive, there's already somebody in here, right? Okay, and you've just arrived, right? I want the expected time in system for yourself. I think this is very similar to the homework question we had. You can break this down into the expected service at server 1 plus expected waiting at server 1 plus the expected, I would say, service at server 2 plus the expected waiting at server 2. Like you have to come in, and if there's somebody already at server 1, you wait, you get serviced, and then you go to server 2. If you have to wait at server 2, you wait, and then you leave, right? Right, so let's take care of the easy ones. What's the expected service time at server 1? Well, 1 over mu1, right? What's the service times at server 2?
1 over mu2.
1 over mu2. How long do you expect to wait at server 1 when you get there? How long do you wait at server 1? There's somebody already at server 1, right? Right when you get there, how long does it take that person to leave?
1 over mu1.
Over mu1.
1 over mu1, right? So then we're just left with this part, right? So expected, I'll call this expected W2, expected waiting at server 2. That's going to depend on whether or not, so let's assume there's a person there, okay? That depends on whether or not I finish first and go over there, before this person's done, or this person finishes and leaves, right? Okay, then I don't have to wait at all, right? Okay, so it's going to depend on the condition of who finishes, what the second event is going to be, really, right? So this is the expected time of W2 given S1 completes first. That means I finish at the first server first. Probability of S1 completes first plus the expected value of W2 given S2 completes first. And the probability of that happening. Okay. So for this portion, what's my waiting time if S2 the person in S2 finishes before I do at server 1? How long do I have to wait for that person? So that's like saying this person leaves first and then I get there. How long do I have to wait for that person at server 2?
0.
0. Answer 0, right? Okay. The first case, what's the expected time that I wait for this person if I walk over there and that person is still there? How long do I wait for that person for?
1 over mu2.
1 over mu2. What's the probability of that happening?
So you finish server 1 server 2.
Yeah, mu1. Yeah, you finish before the person server 2. It's mu1 over mu1 plus mu2. So the answer is, I'll just put, so we're out of time, so I'm going to write it here. 1, 2, 3, and then 4. So your answer then will be 1 plus 2 plus 3 plus 4. I'll put that in different colors so you can see it better. So 1, 2, 3, and then 4. You add all of those, you get the answer. Okay? All right. Oh. All right. We're out of time. So any other last burning questions you may have on this topic? So if you didn't catch everything, I will post this, and obviously the recording gets, posted as well. Okay. Any questions?
Good for right now.
You're good? Okay. So, just do your best on Wednesday. Make sure you try out that trial test on Respondus. And I'll be available to answer any questions today. I mean, there's probably too many people today, but I mean, you could try. I'll try to accommodate whoever has questions. Tomorrow, just email me, and then if we have to set up a Zoom meeting tomorrow, we'll do. But yeah, just you guys have to tell me if you have issues and if you have questions. Otherwise, I'm gonna just assume you're okay, right? So, do your best, and yeah, this is not the easiest exam. I completely understand, but you can do it. I mean, I've done this many years, and many students surprise themselves at how well they can do, right? So, I expect the same. Okay, don't sell yourself short. Set higher expectations for yourself, and get the job done. Okay, and I have faith that the vast majority of you will meet those standards and get it done. Okay, so best of luck, and I'll see you on Wednesday.
Thank you.
Definitely.
Thank you.
Thanks, Dr. King.
Cheers.
Appreciate it.
Bye.